Hi everyone, welcome to the final part of this video series. Full disclosure, I know some of you were looking forward to hearing about impermanence as well as lux. I'll be touching on a couple of things that do facilitate impermanence and lux because Fidgeting Bits is using it for that. However, in my case, I'm running everything through VMs right now for NixOS, and that's turning out to be a huge pain in the ass. Frankly, it's just taking me more time than I'm willing to put in right now, and I want to focus on getting my main system reinstalled with NixOS so that I'm actually using it as a daily driver. So with that out of the way, let's dive into the script. Here we'll ensure that if any command in the script or command in the pipeline fails, the built-in exit utility will execute. So we'll get a cleaner exit state from the script. At the top of the script, we also have several variables, and some of them have default values. Most of these variables can be set using the command line arguments that we'll get into in a second. The target hostname variable is the name of our target machine. The target destination is the IP or domain name. Primary user is the primary user that we want to be installed on the target machine. In my case, I've set it to TA as usual. Then we've got an SSH key variable, which we'll use to provide the path to our SSH key on the source machine. And this is what we'll use to remotely access the target during the installation process. And we can also specify a custom SSH port if we're not using the default port of 22. We've also got the persist dir variable, which will only be populated if the impermanence flag is used during the script execution. This is one of those things that's related to impermanence. It basically sets up the root path for where our persistent files will be stored. We'll get into a little bit more about that further on in the script. The next section includes the creation of a temp directory. We'll be generating the SSH host key on the source host and then passing it to the target during installation. This is obviously important data, so we'll store the key in that temp directory. Our cleanup function will forcefully and recursively remove the temp directory for us. And the built-in trap function will trigger automatically on any script exit signal and run cleanup before actually exiting the script. And this will occur regardless of whether the script succeeded or if there was a failure of some sort due to our setting the exit options at the top of the script. And this will ensure that all of the key data is removed from the source host regardless of the script execution outcome. We've also got some helper functions. The red, green, and yellow functions will allow colored output to the terminal to draw attention where needed, which is handy. We've got a yes or no helper function, which will effectively pause the script execution until we provide a response. Function defaults to yes, so we'll simply need to hit enter to continue. Like I mentioned in the beginning of this series, this is something that we chose to put in because there's some specific cases during testing that you might want to skip over. The sync function is simply a wrapper for rsync utility that passes in values according to the variables set during script execution. And we've got a help and exit function that prints usage and argument information to the CLI for quick reference. And you can see here in this while statement how the various user variables are used during command line execution. So let's talk quickly about this impermanence flag and the persist dir variable. The impermanence flag populates the persist dir variable with the value /persist. This flag should only be used when enabling impermanence, which again, I haven't done for my nix-config. But at a very high level, when using impermanence, the system will be configured to wipe out any data on shutdown that isn't explicitly defined as persistent. Data that are persistent will be stored in a dedicated persist subvolume as defined in our Disco configuration, and that subvolume will be accessible during normal operation and or used to populate other areas of the system during boot. For example, a host level SSH key is typically stored in /etc/ssh. But on an impermanence enabled system, /etc usually gets wiped out every time the system shuts down. So long-term persistent data like an SSH key needs to be stored in a location such as /persist/etc/ssh, so it can be copied to the fresh etc/ssh during boot. In this example, /persist is the persistent directory, and the etc/ssh portion mimics the location of where the data will be copied to. Therefore, by setting the persist dir to a value of /persist, we can ensure that the script will write specific data to the persistent subvolume of the target and that it will eventually be written to the correct system location. When the script is run without using the impermanence flag, persist dir is just an empty string, so wherever we use it in the script won't affect the outcome of a permanent configuration. So next we've got a bunch of SSH commands that are commonly used throughout the script, and setting them up this way just allows for managing the respective arguments in one place. And the fourth one simply provides a quick path to the root of the nix-config repository. So the first big function is NixOS_Anywhere. This function will ultimately run the NixOS-Anywhere tool remotely on the target host, thereby installing the minimal NixOS installer flake configuration that we set up. Before and after that command happens, this function runs several other commands to prepare the target and the source. The individual commands executed in this function are documented in the script itself and are fairly self-explanatory. There are several SSH-related calls intended to minimize additional authentication prompts, although if you're using passphrase SSH keys, there's still a lot of interaction, even if you're using something like SSH agent and a long-duration control path. A temp directory is created to store files that will be generated on the source host and eventually written to the target by being passed to the NixOS-Anywhere tool through the extra files argument. A temporary passphrase is also created just in case LUX is declared as a partition type in the target disco specification. If LUX isn't used, the passphrase is just ignored. So again, setting up LUX encryption is going to be outside of the scope of this series. It's worth noting that this temporary and simplified string value, though, of passphrase is used in the script because there will be no access to sops and nix secrets during this early stage of the bootstrapping process. Following successful execution of this script, you would have to access the target host to change the encryption passphrase to something more secure. Doing this all on headless targets and making adequate use of sops and nix secrets requires some additional configuration that is currently just beyond my abilities while working all on VMs. That said, the problem is something that I intend to solve in the future. With preparations complete, the NixOS-Anywhere tool is instantiated remotely from its official GitHub repo with the following line. Note that the installation process that the NixOS-Anywhere tool facilitates uses the root user that we established in the custom ISO environment. As mentioned earlier, NixOS will be installed according to our minimal NixOS installer flake instead of the full flake because the script changes to our NixOS installer directory prior to executing the command. Once the post-install reboot is complete, we'll switch from using the custom ISO root user to the minimal flake version of our primary user, including the interim password. Lastly, the target SSH fingerprint is rescanned in case of change, and some important files are moved to the persist directory if impermanence is being used. Secrets management being a requirement for us adds some complexity to the entire process, and the main drawbacks being that we can't simply run NixOS-Anywhere as is. Furthermore, creating and updating values in our Nix secrets repo can be somewhat involved. Fortunately, a lot of this we can automate. Generate host AG key, as the name suggests, will generate an AG key for the host to access our secrets via sops. The key will be unique to the host and is derived from the target host's SSH key. Similar to that function, we have generate user AG key, which will generate a user AG key specific to the target host. However, this function will only generate a key for the user specific to the target host if it doesn't already exist. This is because the user's private AG key is actually stored in our secrets.yaml file and is not derived from an SSH key. The update sops file function will add or replace entries in the .sops.yaml file of our Nix secrets repo with either the public AG keys for the target host or the primary user of the target host. The AG keys will have been generated either by the generate host AG key function or the generate user AG key function respectively, prior to this function actually being called. The remainder of the script sequences the order of operations according to several groups of operations that are controlled by the yes or no helper functions. This allows the script to be rerun after a failure of some kind without necessarily executing every operation. As established in the first video in this series, our basic steps for automating the remote installation with secrets handle the following sequence. We'll generate the target host hardware configuration, remotely install NixOS using the minimal flake, generate an AG key for the host to access Nix secrets during the full rebuild, update Nix secrets with that key, push Nix secrets changes to our private repository, copy both the nix-config and the Nix secrets repos to the host for speed, run the full rebuild, and finally push the target host's updated hardware config to our nix-config repo. Steps 0 and 1 are handled by our NixOS-Anywhere function. For step 2, we added the ability to generate a user's AG key specific to the target host, which I just described. This was something that a couple of you had asked about in the secrets management video, and we decided to set it up. For step 5, it's worth noting that we copy nix-config and nix secrets from the source host to the target, even though we also enable repository access, because copying the files this way is typically faster than cloning them from GitHub or GitLab, wherever your repo is stored. During step 6, there's a point where we'll be prompted to enter our primary user password, and since this will be occurring within the minimal flag, we'll need to provide the password that we defined in the minimal configuration. In our case, this is just NixOS. And as you can see in the script itself, we also added in some reminder instructions for cases where we want or need to perform certain steps manually. So let's put it all together. First, we'll build the custom ISO image as described in previous videos and load it into our target host. Next, we'll boot that target into the custom ISO. With the target host booted, we'll simply need to run the automation script from the root of our nix-config on the source host. The basic command is as follows. We specify the target host name, the target destination, and the SSH key that we'll want to use. Once the script executes, we'll be prompted at each instantiation of the yes/no helper function, and we can just press enter to continue because the default is yes. If you used a passphrased SSH key, you'll be prompted to enter that passphrase several times throughout the bootstrapping process. When the NixOS-Anywhere tool is near completion, the target host will be rebooted into the minimal flake configuration. When the reboot is finished, you'll be prompted for the next steps of the process. This may take some time, so just wait until you're prompted. During the final stages of the process, while we're rebuilding the target host to use the full nix-config, we'll be required to enter that password that I mentioned from the minimal installer flake configuration, so in our case, NixOS. As soon as the rebuild is actually finished, our Nix secrets will be in place, and that password will be wiped out with whatever our actual password is that's declared in our Nix secrets. And once the script is fully complete, a success message will be printed to the terminal. This project was a massive learning exercise that turned out to be substantially more complex than I anticipated originally. There are no doubt ways of improving the results, and there has been a constant nagging feel that perhaps I've missed something that is provided in existing tools. But if you're listening to this and you know the error of my ways in light of these environments, I would love to hear from you. This whole project and exercise is about learning as much as I can, failing along the way, and continuing to push through and sharing it with you so that you can learn from my mistakes and we can all get better at NixOS because it's awesome. I hope this is useful or inspiring to you. I'm really thankful for all of the positive comments that you've given, and I'm really looking forward to creating some videos on more specific topics that are smaller in scope. Thanks for watching, and remember, the way out is through.